Welcome back, class, to the Natural Intelligence course, The Blueprint for AI. I'm your host, Norm, and we are going through our final axiom and final lesson for Natural Intelligence 101. This is going to be the SAVE protocol. We're going to discuss forgetting, consolidating, and fine tuning. Your brain deletes what you worked to learn, but that's not a flaw, actually. It's optimization. And it's exactly how AI fine tuning works as well. First, a quick recap of lesson 7, the query function. We discussed the retrieval process and the retrieval practice and how Carpickle and Rodinger discovered in 2008 how memory is built through retrieval, not through storage. We don't want to just amass and store a bunch of information. We need to actually retrieve or recall that information in order for the pathway to deepen and strengthen. We also talked about the spacing effect of expanding intervals to produce a 10 to 30% better retention. This is where we learn a particular topic and we study it in intervals with increasing intervals between those study sessions. So maybe the first interval is you study something on Monday, and then you wait 2 days before you review it or study again. And you're also incorporating some type of retrieval mechanism like a quiz or maybe even giving a presentation on it to recall the information that you learned. And then you would, again, expand that interval for maybe another 2 to 3 days after that, or maybe even 5 days. You would have this progressively increasing interval of spacing between the retention or retrieval practices. And then ultimately, if we learned the AI inference, retrieval from trained weights that we see in AI and the chain of thought, step-by-step structured querying, and that is our bridge to the human natural intelligence process of retrieval. Now, today's class, we're going to learn the biological hardware for the SAVE protocol. The mission here is ultimately to disable the forgetting or the delete key through consolidation. We want to stop fighting your biology and learn to work with it during that pruning phase of optimization. We'll talk about the mechanism of sleep consolidation and synaptic pruning, discovered by Tononi and Cirelli in 2006. And this is where we'll discover and talk about how during sleep, the brain replays or prunes weak connections, right? And this allows you to transfer memories to long-term storage. So you're not just retaining everything in the short term, is actually converting over to long-term memory for you. And this transfer knowledge from the hippocampus, which is more fast learning, to the neocortex, which is a little bit more long-term storage. This is how you have that deep retention in neural pathway. Now, the problem with it is, of course, going to be without optimization, your system or your brain will degrade. So too many weak connections, if you're not pruning and cleaning up your system while you're sleeping, this is why deep sleep is so important, especially as we age. You'll have too many of those weak connections creating a bunch of noise and interference. You're not necessarily getting any value when you're sleeping because you're not getting enough sleep. So you're not pruning. And so you're just basically collecting a bunch of garbage memory and garbage information that's really not retrievable or very helpful for you. And AI models have this same problem that they have to avoid when it comes to overfitting data or even underfitting data models if it's not pruning and fine tuning the parameters properly. Now, the 40% of synaptic strength is downscaled during sleep, preserving signal to noise ratio. So to sort of bring that into a visual, take a look at this diagram of sleep consolidation process. So imagine we're looking at the hippocampus here, here in the center of our brain here. And during sleep, there's a transferring process. You can see this cyan light signal and the glowing synapses here. Being pruned are the red synapses that you're seeing. These are our weaker connections. And these are obviously not very beneficial to us. Either the pathways have degraded over time, or maybe they're just too weak. or maybe they're just, again, not holding any quality information or quality processing. And so what's happening are those dimmed red areas during sleep, they get pruned because we need to make room for more of these healthy, these cyan and gold synaptic processing memories that we're seeing. This is where learning is actually being processed and hardened in the neural pathways. And we want our brain to look more like this gold and cyan and less of this red, right? Less of this red, weak connections because they're not very helpful for us. So that's a way you can just visualize what's happening during our brain. This is it's not just while we're sleeping in our brain. It's also throughout the day, but mostly happens during sleep, during the save protocol. Now, how does consolidation work? Let's break it down here. So there's a three-stage process. And in the first stage, this is while you're sleeping, the hippocampus is going to replay the day's experience at a compressed speed. So things are just going to get really compressed and condensed down to almost like you're watching your memories in fast forward, double time or something like that. Excuse me. Then you're going to have pruning, which takes effect. And this is the synaptic homeostasis, where you're downscaling weak connections. Those, remember on that diagram I showed you, those red areas or red parts of the brain, those are the weak connections. And during this pruning step, you're pruning or removing those weaker connections. And then finally, in the transfer stage, this is where you have the consolidated memories moving from the hippocampus. This is that cyan color moving from cyan to gold, where you get going from fast learning to the neocortex, which is the long-term storage. And as long as it's in that golden state, that's where we want those particular memories to be, because they're, kind of fresh and prime and strong, ready for us to recall on demand. Now, why is forgetting an actual feature? So let's look at Bjork's new theory of disuse from 1994. So every memory that you have, it has two strengths. You have a storage strength and a retrieval strength. So the storage strength is going to be related to how well it's encoded, right? How well did that information get kind of planted or seeded into your neocortex? And then you have the retrieval strength, and this is going to be how easy or how easily you can access that information, right? This is the retrievability or recallability and being able to quickly remember things. Now, forgetting is when retrieval strength is starting to fade. And so this is where the storage strength may still remain intact, meaning the information or the memories are still technically in your brain bank, in your memory bank. But your retrieval strength, it's just harder to go back and retrieve them. And so that's why the retrieval practice works, because it's actually going to continue to rebuild that access path, because the more you retrieve a memory, the more you strengthen that retrieval ability or the storage strength. Excuse me, not the storage strength, but the retrieval strength. And so you want to focus on not just storage strength, maintaining information. That's important. But the retrieval strength is really where you're able to access it, being there, right? Now, we could get into some different sci-fi things of being able to neurologically tap back into some of those weaker strength or weaker pathways, but this is pretty much how it works today. Now, the map matters more than the territory. So we always want to think about organization beating the volume. It's not so much how much information you take in, but how it's encoded and organized in the brain so that you maintain, again, a strong retrieval rate. Another visual aid here, you can see on the left, you've got a gold strength bar here, a little wavelength of some gold constant signal strength beaming out there. And then on the right, you've got a retrieval events. These are these spikes, or every time you try to retrieve information. And, the more spikes you have, you can start to see, or fewer spikes you have, the weaker your strength becomes, and you start to see signal decay with fewer spikes in strength. And so we want to keep those retrieval events as multiple as possible, because again, that's going to lead to longer recallability. Now, what's the bridge from the human side over to AI? So let's look at the human consolidation piece and how it relates to the AI fine-tuning ability. So this is again where we consolidate memories and make the most use of our retrieval and storage strength. And AI does a similar thing where they're doing some pruning and transferring as well. So let's walk through that. On the human side, you have the pruning process, which again takes some synaptic downscaling, where you're removing or looking at pruning these weak connections. And then that same thing happens in the fine tuning of an AI model, where your networking prune or network pruning removes low weight parameters. And parameters are essentially the way that a model calculates or learns about data, learns about what's the best next token to predict. And that's again where you have this thing called back propagation, where those weights get adjusted. And sometimes you could have some poor weights. You could have some low quality weights that produce in low accurate predictions or hallucinations. And so those need to be pruned out or fine tuned. In the transfer stage of the human side, we talked about the hippocampus over to the neocortex migration. Well, in AI, there's a low rank adaptive or LoRa, which adapts a few layers, freezing the rest. And this again is a way of doing fine tuning that is a more optimal way of fine tuning, so that you can sort of focus on a few layers as opposed to having to fine tune the entire model, which can be very costly, very expensive. You could just focus in on a particular, say, for example, if you only want to focus on a particular subject of material or semantic similarity of information. Maybe you only want to fine tune on that particular domain of information or domain or specific tasks. Instead of training or fine tuning the entire model or entire corpus of data all over again, LoRa allows you to do that. Now, in the compression stage, again, we talked about where sleep plays a pivotal role in replaying compression in the episodic or moving over to semantic. In the compression side for AI, it looks a little bit more like knowledge distillation, where you have a large model being distilled down to a smaller model. And, the godfather himself, Jeffrey Hinton, discovered this in 2015, where you can, again, take a very large model, let's say a large, billion, 100 billion, 50 billion parameter model, and distill that thing down all the way to maybe 70 million or 50 million parameters, and still get a quality output from that model, just from, again, fine tuning it and having compression as a piece of the mechanism. On the human side, you have failure, which is, this interference or this old and new memories conflicting. This is, again, where we start to see a little bit of, on the human side, potentially not just forgetting, but on the AI side, we have just not just forgetting, new training overwrites old. It's more hallucinations, right? And we have a little bit of that on the human side, right? When we're starting to forget things, we maybe think things happened that maybe they didn't happen, or we mismatch, maybe an event with the location, and we think that this event happened at this particular location, but it was actually correlated to a different event. But we conflate the two or combine the two. And this is where there's some failure there, some interference with maybe additional noise or weakened pathways. But all that happens when you're not retrieving often enough. And this is just a visual, just to give you an idea of how our human brain, with the cyan and the golden synapses here, again, that knowledge transfer and memory transfer occurring. Same thing is happening on the AI side in our neural network that you see here across the different layers. At each node, there's a calculation essentially happening with the parameters, and we can see the weights being lit up, and each of these nodes, these little dots, those are nodes that are happening. But at each one of those nodes, there's a calculation being performed, and that calculation is essentially helping that neural network, or the brain, the AI brain, understand the data better and be able to find patterns so that it can predict with high accuracy the next best token. Now let's talk about how we will breach the protocol. Let's go into system optimization strategies. We'll first talk about the protecting the consolidation window. Sleeping 7 to 9 hours. Okay, I know many of us, especially as busy professionals, and especially if you have families, that's a little far-fetched. But sleeping 7 to 9 hours, this is when we have that replay. And this is, again, where all that pruning and the transferring happens. So studying and then sleeping is far more effective than just trying to cram, stay up all night and study as much as possible, it seems like you're doing yourself a service, but it's actually counterproductive to spend all night studying and not sleeping. You actually need to sleep. Now, the number two, on the front load signal, this is where the brain prunes based on signal strength. So it's going to look for the weakest areas or the weakest pathways and say, okay, that area is pretty weak. I'm going to focus on that and clean that up first. And this is where memories that are emotionally tagged, have high salience, or recently retrieved are more likely to survive pruning because they're going to essentially get skipped. They're going to get passed over because the front loading the signal is going to allow your brain to go to the more weaker areas first. The space consolidation, this is where you have multiple sleep cycles between study sessions. And this again is going to allow for layered consolidation. So one night consolidates, a week transforms memory into permanent storage or permanent storage, excuse me. And so this is again where you're stacking or building repetition in, not just with your retrieval, but also with your consolidation or optimization by sleeping in consecutive nights. And then four, you have the audit retention finally. And this is again where you be able to audit yourself or test yourself before restudying. So if you can retrieve it, you're studying or you're studying in your consolidation actually worked. But if you're not doing well on that retesting, on that audit, then you probably need to re-encode with higher salience, find some ways to, again, attach some type of emotional connection, making hooks to previous schemas in your framework already, and then try to retrieve again. Now let's look at that broken down, this optimization cycle in a visual just to help us here. You have this circular optimization diagram where we have encoding. This is essentially the information going in and being encoded, planted into our brains. Then we're going to generate information, which is, think of it as trying to recall or, talk about it or answer on an exam. That's our generation phase. Then you're going to have this next step of the retrieval step, right? Retrieving it, which we know that that's actually calling the information, recalling information, very similar to generation, right? These sort of blend into one another. Then we have our sleeping, and then while we're sleeping, we're pruning. And then you have the cleanup stage of transferring and pruning after we're sleeping. And then it kind of goes in this cycle again, starts all over again with retrieving again, testing, auditing. Then if you need to study more or bring in more information, bring it in a different way. This is, the encoding phase where maybe you try to study by reading the material, but maybe you change in the second cycle, this time when you're encoding the second time around, rather than just reading to study, maybe you try to watch a podcast or maybe watch a tutorial. And that's a different type of encoding of the information going into the brain. So now you say, okay, I tried a different encoding method. Now let's see what happens in this cycle. And we'll go through the full cycle again and do a retrieval and audit of that retrieval, and then find out if indeed that was a successful encoding. And then the cycle just continues, right? There's just this continuum of a cycle of encoding, bringing the information in, generating that information, trying to retrieve it, and then sleeping, pruning, or optimization, and then testing it and all over to the beginning. All right, now what's our build objective for this lesson? We're simply going to be designing a system optimization plan, and it is our final tool that integrates all 7 of our components from the Natural Intelligence 101 stack. So this rounds everything up. You'll have all 7 sort of objectives built and tools ready for you to go into learning our next course, Natural Intelligence 201. So you'll be ready and armed to go. Now for our architects, you guys are going to be designing a system optimization template where you'll have a reusable framework that maps all 7 tools to a specific learning goal. And then you'll be including consolidation windows and audit checkpoints. For my builders, you all are going to focus on building a system optimization agent. So we're moving a little bit further away from just a system prompt to now having some type of agent. And so we'll have a system prompt that takes a learning goal as input and outputs a complete optimization plan using all the 7 tools that we've learned over the past 7 lessons. So this will again include the consolidation schedule that we learned tonight. Now, what are the requirements for the template for our architects? We're going to go through this process or this workflow of define, map, schedule, audit, and iterate. During the define phase, you're selecting a learning goal, what you need or what do you need to learn and by when. We'll map things, so we'll assign each of the 7 tools to our learning plan. So we'll go back to our first axiom, which is salience, our second axiom, chunking, third axiom, dual coding, schema, generation, retrieval, and consolidation. So again, bringing all of our all of our tools together here, and then we'll schedule it. We're going to build a weekly calendar with study blocks, retrieval sessions, and sleep protected consolidation windows. Don't forget the sleep portion because that's when we're pruning and optimizing. Then we're going to audit. We're going to check ourselves. So we'll set some check-in dates or some checkpoint dates to test ourselves on our retrieval ability. And then finally, we'll iterate, right? So after each audit, we'll just do a quick reflection. We'll look in the mirror and see how well we performed and what do we need to improve upon. Now for the builders, your optimization agent will look similar, a little bit different though. So your system prompt must include or must instruct the AI to accept a learning goal. So you're going to give your AI, your large language model, choose whichever one you like, whether it's Gemini, Claude, or GPT. And then you're going to generate a complete 7-tool optimization plan for all 7 of our axioms from salience all the way to the current consolidation. Schedule your space retrieval sessions. And this is all going into your prompt, by the way. So make sure you're designing your prompt in a way to include this information. Then include consolidation windows, which would be your sleep protected blocks. So when are you sleeping? How long are you sleeping? What time you go to bed and wake up? Build a routine around it. Then number 5, you're going to output an audit protocol with checkpoints and re-encoding triggers. So this would be the audit phase of everything. And that will complete the full stack from high salience, chunking, text to visual for dual encoding, schema graphs, generation loops, speed retrieval, and finally system optimization. All right, that wraps up today's lesson. Now, what to remember. So first, forgetting is a feature, not a bug. Synaptic pruning removes weak connections to preserve signal to noise ratio. We have sleep consolidation, replaying, pruning, and transferring memories from the hippocampus to the neocortex. And this is what we call the system consolidation. Our AI branch to fine tuning is the to human consolidation. And some examples of fine tuning in AI would be the LoRa or low rank adaptation mechanism or technique that adapts specific weights. And this is where we're pruning removes low value parameters and distillation compresses large to small. So again, choosing a few layers or a few parameters to focus on as opposed to the full map. Bjork's 2 strengths, storage strength and retrieval strength, right? These were the 2 different strengths that we want to focus on. A lot of times as learners, we tend to focus on the storage strength and not necessarily the retrieval practice or retrieval strength. And so we need to make sure we're practicing often or testing or recalling the information very frequently, because again, we know that the brain will prune the weaker areas first, but the things that get more repetition and retrieval, that have more emotional connection, right, has higher salience, those are the things that the brain is going to sort of bypass first and look for the weaker connections. And then finally, we completed our stack, completed our course here essentially, really, right? We completed all 7 axioms from high salience all the way to system optimization. And so next up, we'll talk about the capstone, our neural twin, and then we'll be moving on to the next course, which will be our Natural Intelligence 201, where we'll start talking about some system design and thinking like an engineer and preparing ourselves to start building artificial intelligence systems. All right, gang, thank you so much for your time today. I enjoyed giving you this lesson and also the course, Natural Intelligence, the Blueprint for AI. So make sure if you've missed any of the previous lessons, do go back, watch the lessons. You can watch them in any order, but they are designed to be watched in order from lesson 1 or lesson 0 all the way to lesson number 8. So please do go back, take some time. They're not too long. I try to condense these down, break them down for you, but go check them out on the YouTube channel. Have some fun, practice them, put them into practice. Don't just review, right? You need to actually retrieve and test and use the information in order for you to learn. And then pick a topic, pick any topic that you want. It doesn't necessarily have to be AI, it can be any topic, and try to use these techniques on any topic you're trying to learn. Maybe you're trying to become a very good bachata dancer, or maybe you want to learn Spanish so that you can watch the Super Bowl performance. Who knows what you're trying to do, but use these techniques and these axioms to better your learning rate and your learning efficiency, so that you can, again, stay ahead of AI and stay relevant and continue to add value to your family, your friends, your workplace, and your business clients. Until the next class, take care, be good to each other, and I'll see you soon. Class is dismissed.